Okay, so hopefully this is recording. Guess I'll find out. So these are hints for the mountain problem in 4.3. And for my spring 2014 students, this is a bonus question, provided it's turned in on time and correctly, so worth 1 point. And the question is, how do you find the height of a mountain? Well, you can't actually just measure the distance from the base of the mountain to wherever you're taking your measurements, because there's a mountain in the way. So what we have to do is we do this angle side angle setup. We take a measurement at some distance and we say, what's the angle between the ground and the top of the mountain? Use, a device that has a protractor in it, and it has, you could make one very easily out of cardboard and string, and you can download those off the internet. Okay, and so you can stand again like 10 miles away and say, I'm much closer. Now it's a 15-degree angle. These are basically bogus angles, but they work for the purposes of the mathematics. Then you know from trigonometry that if you have an angle side angle situation, you must have unique values for this whole setup. Okay, so how do we make use of the fact that there are higher power tools that we're going to learn later in the semester that will allow us to do this more easily and quickly? But we already have plenty of tools now if we just cut the triangles appropriately. How do we do that? Okay, first of all, we draw in a whole bunch of angles. So the first thing I calculate is I had the 15 in blue, that was given, and the important angle is this 165 that I drew in green. You also draw all these, the base of this other triangle in, and so what happens is we were given the 4 degrees in the problem, we were given the 15 in the problem, which means implicitly we were given the 165. But if we draw this picture, the 90 is understood. So the next thing we figure out is, well, this guy must be 75 because he completes a triangle. And we also can figure out that this has got to be 11 because that one completes a triangle. So we can figure out all these different values, and that will help us tremendously in the next step. Okay, what's the next step? We're going to actually erase the mountain. So I want you to look at this part of the diagram next. This part of the diagram is what I'm going to talk about. And what I did is then I just flipped this around so it was easier to work with. Because this angle is so obtuse right here, it just made it really hard to draw on it. So I just drew the whole thing over again. I happened to flip it in the process of drawing it. So this right here is now, right here, this is the height of the mountain right here. Okay? And here's the 2 observation spots. Alright, and so what I'm going to do is I'm going to do the stuff that's in black first. I'm going to drop a perpendicular from this corner onto the opposite side. And that means these 90-degree angles are given because we constructed it that way. Once we know that, then we can just find out that that's 86 and that's 79. Okay, it's got to be that way, and then this adds up to 165. Everybody's happy, right? Okay, so then the next thing you do is you just ignore this side. Well, actually, I'm sorry. You ignore this side of the problem, and you just use this triangle and the 10 miles to find this black height, the height that you just created. Okay, once you do that, you then ignore this side of the triangle and just use this piece of the triangle. And you say, aha, so if I know that, now I can find this side. Once you find that side, then you can find the height. So the order again is, first you find this guy, then you find this guy, then you find this guy, and then you're done. Okay? So hopefully that's enough clues to help you guys, and you can have fun with this problem.